Hi everybody, and welcome to this video about using Postgres with Node.js. This is sort of exciting. We get to combine our knowledge of Postgres and SQL, which we've been working with in that SQL module, with the knowledge we learned in this module about how to handle Node.js, how to work with JavaScript, how to get a basic server running. And we're combining those to get a data-driven or a database-driven web application, or at least the back end of that database-driven web application. The example we'll be using is one that we're familiar with the Postman video. It's the one with campgrounds where people can get basic information about campgrounds. For example, in that Postman video, we saw this request, an info request, where it takes one argument, Q, which is the name of a campground, like Wolf Hollow. It searches the database, and when it finds information about that campground, it returns it in a JSON object, like shown there. If it doesn't find any matching entry in the database, it'll return that 404 error, that not found error. And I put a red box around it because it's not, I don't know if it's controversial is the word for it, but some developers will use a 404 error. Other people think, well, that's sort of bad form. And it varies quite a bit, especially in these simple search cases. It's kind of an edge case where you could do a variety of things. And it makes sense. Maybe a 404 error means page not found. Some people believe that should just be reserved specifically for pages not found. But our queries might look like web pages, so it might make sense for it to return a 404 error. So for example, that first entry, Q equals saddle, where we have that a key and a value pair, that doesn't look too much like a web page, but we can also represent it as in that second example. We'll look at this when we look at React. And that does look like a web page. So maybe we do want to return a 404. Other people say, well, we should probably just return an empty list, an empty array, signifying that nothing's found. So that might work out well. So we have this option. We can return 404. We can return an empty list. We can return something completely different. And for the purposes of this video, I've selected something kind of difficult just to be able to highlight how to do more complex things or how to construct more complex JSON objects. And we're going to have this status field. So we'll say status OK if we found something. And then in the results field, we'll list the results that we found. And if it wasn't found, we'll just say status not found, and we'll echo back what the search term was. So that's what we'll do now. So there's three options. We could return a 404 not found error. We could just have an empty list of things. Or in this case, we can just we can be a little bit more specific and add an entry in. That's probably not, I don't know. It's hard to predict what the best thing is to do, but we'll go with this just because it illustrates some additional complexities. Then there's this near request. So basically we're asking, hey, what campgrounds are near a particular city? So in this case, what campgrounds are near Ruidoso? And the key there is the name city, and the value is something like Ruidoso. And if it finds something, you can see what the response is. It's very detailed, and so the status is okay. And the results will list what city it is, Ruidoso, New Mexico, and what campgrounds are in that city, or what campgrounds are near that city. And if not found, we'll return something very similar to the info get request. Finally, we'll be able to add entries into the database. So for that, we'll use an add post request. And the values there will be URL encoded body arguments. So we have things, the keys are name, city, description, and toilets. And I give sample examples or sample values there of what that would look like. So if we were successful, we'll just say again, status OK, and we'll just echo back the city and the campground looking like what's on the left. And if it's a duplicate entry, we'll say so. We'll say status not added duplicate entry. So that's what we're trying to implement. So here are some preparation steps. First, I provide an SQL file. So later on, we'll learn, well, how to think about creating an SQL file for a particular problem. In this case, one's provided, and we go to that address. Let me go ahead and do that and get everything set up. Okay, here I am in my browser. I have that link copied, and I'll just paste that link in. And there's that SQL file, so I'm going to just simply save it. And make sure I save it as not a .text file, but as a SQL file. All right, sweet. Okay, so we've downloaded that file. Now let's have a look at that file with a text editor. So here's my text editor. I'll open it. And this should look familiar to you because we've worked through tons of examples like this. So we create a database called Parky. We change into that database. We create a table called campgrounds with that information, ID, name, closest town, description, and restrooms. And then we insert some entries into the database, just as an example. And here we grant permissions on that table, campgrounds, to a user called Parky. So we're letting Parky select and insert on campgrounds. And because we have a serial here, this ID number, we have another sequence called campgrounds ID sequence that we have to grant permission to. So I'm granting usage on campground ID seek to Parky. So that again, so serial auto increments, and this sequence, campgrounds ID sequence, is what maintains where we are in that incrementing sequence. Hope that explains that. So why am I using Parky here instead of Postgres as the user? Well, Postgres has kind of administrator privileges on the entire database server, right? So if I use that in my web application, and if my web application is compromised, I've just compromised everything on that database server. So that person who compromised my web application can delete and drop databases, can look up things in some password table, can do all sorts of wonky things that we get credit card information perhaps. So we don't want that. We want to minimize the impact if something's compromised. So we get a user, Parky, and we're going to grant really minimal permissions on Parky, mainly the select and insert on campgrounds, and to allow it to use that ID, which is a type serial. So, all right, so let's go into Postgres and get this working. Okay, so now I want to create that user Parky. And now I want to set Parky's password. So here I have a choice. So in development, I might want to have like a trivial passwords, one easy to remember that I can work with. But then later on, when I push this to production, I'm going to have to remember to change that password to something difficult and harder to guess because I don't want people to compromise my web application. So one option is start easy, but just remember to change it later on. And the other option is, I guess, to start hard and just, deal with it. And I'll go with that start hard, let's just deal with it option. So here I am in my browser. I'm going to use LastPass to generate a password for me. And that looks good. Why not use it? So I'll just copy it. And I don't want to forget it because at least temporarily I want to put it somewhere. So I'm just going to paste it here and as a comment just so I remember it. And now I'm going to use it. Okay, so now I created the user Parky. I've given Parky a password. Now I'm going to load in that SQL file. All right, that looks good. So let me get out of here. And let me log in as Parky. And since Parky is the same name as the database, which is Parky, I don't need to specify what database to log into. But if it was different, I'd have to use this -d command because that's the only database Parky has any privileges to. So I'll just add that in just to show you what that looks like. And now I'll paste in that long password, and I'm in. So let's just take a look at it. Let's do just get the names from the campgrounds. Okay, so that's the names. Let's see if I can delete Apache Creek. Okay, well, good to know. We don't have permission to do it, so our permissions work. So we've kind of, again, limited what permissions Parky has. So I think we set everything up. So let's quit this. and go on. The next thing we have is a Postman Collection. This can be used to test, as we're writing our application, we'll be able to test it. So let's go ahead and load in this Postman Collection. So here I am in Postman. I can import. I'm going to import from a link. I'm going to put in that link. And it says Collection National Parks imported. My national parks are up here. There's 11 requests. I can see them. I have Get Apache Creek, Get Pinon, and others. So that's my national parks collection that we'll be using just to test and run through our code as we write it. Before we get started writing that code, I just need to cover one additional thing, and that's how a web server interacts with a database server. So it looks like this. So on one side, the left side, we have our web application. So that would be written in Node.js. And on the other side, we have our database server, in our case, Postgres. And here's what the interactions look like. The first thing we need to do is open a connection. This is sort of like, and I'm hand waving, and it's close to, but not exactly. This is sort of like what we do when we type in PSQL, user, Postgres, whatever. So we're making a connection to the database server. So those are sort of equivalent. The next thing we do after we logged in and also holds for the application is we send some request, like some select statement or whatever we need to do to get some information from the database server. The database server sends a response to the application, and then that connection is closed. So every time we get a request from some user goes into our system, our campground lookup website. Every time they type in a search, we open a connection, we send a request, we get a response, we close the connection. We open a connection, send a response, or send a request, send a response, we close connection. Doesn't take a lot of time to open a connection, but it takes some time, and we don't want to keep opening that connection over and over again. It adds up. There's some overhead involved there. So what we do instead is what's called a connection pool. This is how it roughly works. So if we want to make a request, the first step before was opening a connection. Now, ahead of time, what we're going to do is open up a pool of connections, a set of connections. So we have these connections to our database just waiting there. And when we need to send a request, we'll just use one of those connections. So we open a bunch and we use them as we need them. So graphically, it sort of looks like this, that we open a connection pool that creates a bunch of connections to our database server. And then when we make a request, we can just use one of these connections that are already there. So that's what a connection pool is. It just adds to the efficiency of the way our web application interacts with the database server. And that's what we'll be using. Sweet. All right. So now let's get started. Not exactly writing the code, but the precursors of writing the code. All right. The first thing is let's make a directory called campgrounds. Change into that directory. And here's where we do what we learned to do, this npm init. And this time I'm not going to go to kind of step by step through all those questions. I'll just say, hey, say yes to all of them. So that's that. And now we need to install some packages. Last time we learned how to install Express. This time we're also going to add that Postgres module that'll enable us to work with Postgres. So we're going to do that. Sweet. That all looks good. All right. Now I think it's time to get into the file and start editing away. Okay. Let me do that. And all this will look similar to what we've been doing before. Let me see how fast I can actually do it. Let me just save it first. I like saving it first just so I can get color-coded, syntax highlighting. Okay, loading in that Express module. That body parser we talked about before, which had to do with being able to read post requests. Now we create that Express app. Let's run it on port 3000, a very common one for these Node apps. Okay, now we get to the interesting stuff about how to use Postgres and that Postgres pool. So here I'm just loading in that module, and in particular the pool part. And now I'm just going to create a constant that gives the required information about how to log into the database server. We'll see what that means shortly, so I'll just call it config. All right, and this is the stuff, how do you log into the database server? That's what we're telling it. So we're saying the host it's right here on the same machine. It's the local host, right? Because the host could be on another server somewhere, so we'd give it an IP address. The user we're logging in as is Parky. And fortunately, I saved that password. Could probably get rid of it now, but I'll hold on to it just a little longer. And finally, what database we want to connect to. So again, this is helping. Once we get the pool running, we're just telling it how to log in. Now here, we're going to say, hey, log us in. All right, so that's the kind of the header. That's not a technical word, but just kind of a description of what we did, kind of the boilerplate of what we have to do just to get started. And let's just do a simple hello world like we did before, just so we can do a little test and see if I have any typos. Let's just say it's going to respond to hello. And that, remember, it takes a function with a request and a response. And the only thing I'm going to do is response JSON. Okay, and now the bit of code that starts everything up. Just going to copy that because I'll need it later. Create a function. Oh, sorry, my error. Need to do backticks since I'm replacing a variable there. Okay, got that fixed. All right, save it, and let's see if it runs. That looks good. And let me go to a browser, type that in, just to test our simple. And there we get hello world. Great. So now we know all the little bits are working. Now we can work with that actual info request. Here's that info request, just as a reminder. So it takes an argument Q, which is the name of a campground. If it finds the campground, it'll give that status OK, and the results will be what it found in and part of the database search. If it didn't find it, it'll say status not found. All right, so that's what we're trying to implement. Let's do it. Okay, so it's a GET request. And here is what we're going to do in here. We're going to query the database server. We're going to query the Postgres server. And that, as we were talking about in the asynchronous video, takes some time. So here's where we're going to create an async function as described in that video. So now we think, well, we know that the term we want to search for is request.query.queue. And now we need to kind of convert that into something that we can actually, some SQL statement that we can get that information from the database. Let me zip to the database here. So now we can see what the structure is. And now we're thinking, well, what's the select statement that we can use to search for the name of a campground and return all the information? I'm hoping that that's a bit trivial for you, so let's write that select statement. So that would be something like select, and we want everything from campgrounds where name equals whatever the name is, right? Because that's what we have here. Get everything from campgrounds where name equals whatever the name is. All right, let's see how we can do this. So I'm making a request to a database, so I'm going to stick it in a try. And let's kind of make a template of that query. So that's select splat from campgrounds where name equals, and I don't know what that's going to be. I'm just going to stick $1 here. So that's sort of the template we'll use, and we'll plop it, wherever $1 is, we'll plop in what we're actually searching for. That's the idea here. Okay, so and now let's actually query the database. Here we're going to use that await because we want to temporarily suspend the operation within this function until we get a result back from the database. Remember that this async function, it doesn't wait for the async function, we just keeps going, but within the async function we're going to wait for the database response. Okay, and pool.query takes two arguments, a template, like I just showed you, and a list of what to substitute. So what to substitute for $1. And let me just give you an example of that. So I'm going to get rid of this in a second, but I just want to, let's say, and x equals $2 and y equals $3. So now if I have things here like and, there'd be three things here to match the 1, 2, and 3 in the template. Poodle, dress, I don't know. So what happens here in this pool query command is that this $1 in the template gets replaced with an, this $2 in the template will get replaced with poodle, and this $3 with dress. So we'll get select splat from campgrounds where name equals and x equals poodle, and y equals dress. Doesn't make any sense, but I think it at least illustrates what that substitution is. There's another video coming up that'll explain why we do it this way versus some other ways that we could do it. So let me get back to my original one. So this is going to contain what we want to replace 1 with, and that's whatever the user sends us. So that's rec.query.queue, right? And now let me just console log that response just so we can see what it looks like. And that'll help us figure out what code we should add next. Let me just catch that try before we do that. So we could have constructed the query using this plus, but as we'll see shortly, that's a really bad thing to do. So don't do making a query with this plus. Always use this pool query to do the substitutions. All right, so let's say that's good, and we'll see how many errors we potentially have. We stop my server, start it again, and surprisingly it still works. All right, now let's go to Postman. Here I'm in Postman, and I'm just going to go to this get Apache Creek. And it's not going to return any response because I don't have response.json, so it's just going to hang sort of. But at least we'll get to see what that response is that we get back from the database server. So I'm going to send that. And it's going to hang here, so I'm not going to even wait. And here we get what we get back from the database server. And it starts here with result. And we see we have this thing called row count, which tells us how many entries matched the search. In this case, it's 1. We were kind of expecting it. And we could get back 0, meaning that select statement didn't return anything. We didn't find anything, so that's useful. And you can see the results are in something called rows, right? So we have a list after rows. And so this entry here, this Apache Creek entry, it would be rows 0, right? So the first entry. So row count's important, as is rows. So let's go ahead and, with that information, finish off this function. I guess I don't want that anymore. So now we got a response back, and we want to see, hey, did we get any results? So let's check first, let's see if we didn't get results. Right? Hey, we didn't get anything back from our database search. That we wanted to return not found. And the search term we used was rec.query.q. Right? So that's cool. So in this case, we did get a response back. So that was in rows 0. And just for completeness, let's get a response if there was some other error. Oops, I see my error here, which is here. Hopefully that will line things up. Yep, that looks good. So let's save it. Okay, let me quit, start again. Wow, that's worked. All right, and let's try it this time. So I'm going to send that request in. And this time I got 3 of 3 tests passed. So I wrote a good query here. So let's take a look at what the tests were. So I checked the status if that was 200, and so apparently it was. That passed. I checked to make sure my status was okay, which it was, and then it checked a few of the fields that it were returned, namely Apache Creek and then the city Reserve, New Mexico. So that's cool. Let's try this next query. This is searching for Pinon. I added this one just to see if it handled UTF-8 characters, so that N has I don't know what that term is for that accent mark, but it has an accent mark over Pinon. So let's send this to see if there was a problem. And my test results were 3 of 3. They all passed. Status code is 200 passed. Check status and check result all passed. Next, I'm going to check for Taylor's Railroad. That search term has an apostrophe or a single quote in the name. That's problematic sometimes, as you'll see in the next video. So let's just check if that works. That worked fine. The test results were 3 of 3. And now for the final test, the non-existent campground where I'm searching for Smokey Bear, which is not in the database. And I'll send that. And it passes 3 of 3 tests. Sweet. So, hey, no errors. Things seem to be working. So that's cool. So let's implement the next one, the near command, or the near request. So the near request looks like this, where it takes an argument city, that should be lowercase, and for example, Ruidoso. And if it finds the city, it returns this complex-looking thing with results OK, and then the results echo the city and give a list of the campgrounds. And if it doesn't find it, it'll return what's shown here on the right. Namely, the status is not found. All right. So as you can imagine, that's going to mirror pretty much what we just did. So let's go ahead and get that running. Okay, now here we need to do that select statement, and let's take a look what that is. So the search term is, we're going to search for a city. So here we see the fields, so that helps us determine what the command will be. And we don't want the entire information, we just need the name of the campground. And here we're going to use that template. The $1, we'll replace that with what we get in. And let me just say a few things. First, these names are just names I invent, template and response. You can name them whatever you darn well want. And second, as I'm using the new kind of constant, and if I needed to, a let to declare a variable. And the old way was with using var. So if you see var, just think, well, that's the old way of declaring variables. It's not used anymore. It's kind of frowned upon, but you'll see it crop up here and there. So that's how to declare variables. All right, so we're going to replace that $1 with rec query dot city, and we'll check the same thing. So in this case, it didn't find anything, so we'll do that JSON. Okay, that looks good. Let me put it in the right spot. So here's where we want the results to return. And I'm just going to do this temporarily so we can see a problem and go from there. Okay, got that. And then we had results, I think, which included, I made it pretty complex. Okay, and that was city. And we want that to be rec query.city. And we also wanted campgrounds. And here's where we'll go response dot row. So we want all the campgrounds. Okay, as I said, this is going to not give us the results we wanted, but it'll get close and we'll revise it. Okay, that's the try statement, so let's catch the error. Oh. All right, I think everything looks wonderful. Let's give it a shot. There's going to be a big error probably. Oh. So let's give this a shot. Let's go switch to near Ruidoso. So we're looking for campgrounds near Ruidoso. And here we get this failure of 3 of them. So let's take a dig deeper here. So we got the 200 status code. That's good. The status check was the OK check. The result was checking a city. We can look at that in the tests. The result check. And then there were these other tests that it failed on here. So let's look why. So we are expecting this, a list of names like 3 Forks, South Fork, 3 Rivers, South Fork, Oak Grove, Scorpion Ridge. So that's what we were looking for. And what we got back was a list of JSON objects, name, 3 rivers, and so on. So that's not correct. It gives us an opportunity to try out some JavaScript skills here. So let's go ahead and fix that. So we don't want to return response rows. We want to massage that to just get back the actual names. So before we do this response JSON, I'm going to do that. Let's call it camps, for short for campgrounds. So response.rows. And now we're going to just run over we're going to do a map function. So for each element in the list, rows, here's this function to execute. It's going to take that entry, which is a JSON object that has name, colon, the name of the campground. And it's just going to get that name. So here I'm constructing camps. It's just going to be a list of campgrounds. We're going to get rid of that key name. So here, instead of response.rows, I can just put in the word camps. So let's see how that works. Stop the server, run it again. Now I'm here, and I'm going to send that information. And it passed 6 of 6 tests. So see how it comes back with that nice list of campgrounds. How did we do that? We did it by applying that map function. Sweet. Let's try it with the other requests. Okay, let's try this Doniana one. The same thing with just testing UTF-8 characters. And it passed 4 tests. That looks good. The Eagles Creek, the single quote mark in Eagles. That passed fine. And finally, let's check that non-existent city. And that passed fine. So we have successfully implemented that /near. Our final thing we want to implement is that post request add. Let's take a look at that one. So here's that add post request. So it's going to have the arguments in a URL encoded body. And the keys are name, city, description, and toilets. That toilet should be lowercase. Sorry about that. And those are the sample values. So if it successfully added a campground, it'll give the response on the left that the status is okay and just kind of echo back the city and campground. And if it's a duplicate entry, it'll say so. It'll say status not added, duplicate entry. So let's see how we can do that. Okay, that's going to be an app.postRequest. Add. Now, again, it's going to access the database, so it's going to be async. And I'll do that same block. I might as well just do it in a different order here. Okay, so here we want to add an entry into the database. Here's our database. That's what the table looks like. So that's the basic try catch block. Before we do that, let's actually get the arguments in some easy to read form. And let's just say, the name of the campground is going to be rec.body.name. Let's call this town equals rec.body.city. Right, so the name, city, those are things being passed in. The keys that are in the body, these are just names I'm inventing. I'll just call it DESC for description equals rec.body.description. Whoop. All right, I think that looks reasonable. So here let's continue calling it template, I guess, I don't know. So here's where we want to insert something into the table, campgrounds. So let's take a look at that table. Here's the table. We have ID, name, closest town, description, and restrooms. We should be able to write that. So that's an insert statement. Insert into campgrounds. And then the names of the columns that we're inserting. So it's name, closest town, description, so we're inserting names, closest town, description, and restrooms. So we got these names from the database. They don't match these up here. They're matching what we call the columns in our database. So we have name, closest town, description, and restrooms. Here's where we're going to include those entries that a person sent to our server. So that's $1, $2, $3, $4. So that looks reasonable. Let's just check it out. Insert into campgrounds, name, closest town, description, restrooms, values 1, 2, 3, 4. I think that's good. You are probably seeing something obviously wrong. I'm hoping it's not wrong. But okay, so now here we're going to get that response back. And we're using that template. Again, that's just a name I invented. And now here's the arguments we want. Well, they are name, town, desk, and toilets. Okay, and so if this fails, this is going to go into the catch block. So I'm going to have to revise that catch block to match what we listed. So, but if it succeeds, then what we want to do is res.json. We want the status to be okay, and the results to be the city. We want it to be the name, and the campground will be the town. Otherwise, we're going to return status. Else, we're going to write not added, duplicate entry. I'm pretty sure that's what it was. And then the campground we were trying to add was name. And it's a JSON object, which I didn't do. All right, that looks reasonable. Let's give it a shot. And I'm going to move to that add Scorpion Ridge example. Whoops. So that body had name, city, description, and toilets. So let's send that. Oh boy, I made a mistake on this one. And it missed the third one, which is expected scorpions ridge to equal Mimbres, New Mexico. All right, what did I expect here? City and campground. Oh, did I screw up? So I needed... So let's see what I did wrong here. So, I I got the order wrong here. So this should have been town and this should have been name. Sweet. All right, so let's see if that works. I save it. Stop and start my server. Send this again. Oh, okay. So now here I'm having a further problem in that I already added it, so I'm getting the duplicate entry problem. So now what I'm going to have to do is reload my database. So let's see how fast I can do that. So I'm going to stop my server. Again, the problem is because I already added that entry, I can no longer test for it, so I have to get rid of it. Okay, and let me quit. And now start the server again. Okay, now I'm going to send this off. Please work. Yes. All right, so I passed those tests. That just made sure it returned the right thing, but we don't know if it's actually in the database. So I'm going to check that by this check database add and see if that returns correctly. It does. It passed 3 of 3 tests. And now let's check to see if I get that duplicate entry when I try to add it again. So the same body's the same. I'm just trying to add it for a second time. And that passed as well. So there, we've implemented this API. I hope it was helpful to go through all this. So the new stuff really was this idea of a connection pool. We had to write this config JSON to be able to log in. And we need to use that async, await functionality to make things asynchronous. I hope all this was helpful. Take care. See you in the next video, which is about SQL injection. Bye.